Hi everyone, thanks for looking in on this video. It's Friday night and I wanted to go over our practice quiz. It's the one I handed out on Friday. If you left your paper at school or lost it, that's just fine. I'm going to put each problem here on the screen. My suggestion is that you write the problem down and try it. Hit pause on the video. See how you do. If you get stuck, hit play again. Watch me do the problem. The test is pretty much what I told you in class. It's systems of equations. It's going to be split up into three sections. One is graphing, one is substitution, and one is elimination. All right. I'll probably have, I think my format for the test is I'll probably have 3 or 4 multiple choice questions, then one show me your work with each of the 3 categories, graphing, substitution, and elimination. All right, let's get started. The first ones up are graphing. All right, number 1, we've got 2 equations here, y equals minus 2x minus 4, and y equals negative 1/2 x plus 2. Just as a reminder, okay, both of these are negative slopes, and negative slopes go in this direction. Had this been positive slopes, they would have went in this direction. All right, let's go ahead and put these on the graph. All right, y equals negative 2x minus 4. The y-intercept is the negative 4. So I'm going to go down to negative 4 and mark it. All right, I know the slope is going to be negative, and it's going to be its rise over run, which means it goes up 2. That's the rise, and the run is 1. 2 over 1 is 2. So let's do this. Rise of 2, run of 1. 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 All right, there's my straight line. All right, go ahead and draw this and put it in. There's my first line. All right, the second one, the y-intercept is 2. When I say the second one, I mean y equals negative 1/2 x plus 2. That means that the y-intercept is right there. All right, again, I know this. It's going to be a negative slope, and I know it's a rise of 1, a run of 2. So let's put that on there. Up 1 over 2. Up 1 over 2. All right, I can do these backwards, okay? It's over 2 down 1 when you do it in reverse. But you can tell the slope is still negative, and it's a rise of 1, a run of 2. This is all the points I need to put on here. I connect these. All right, I can see that the point where they intersect is right here. It's at on the chart on the plane. It's negative 4, 4, negative 4, 4. I can put in a point like that, or because I know that it's x and y. Okay, I know x equals negative 4, y equals positive 4. All right, I will accept it like this, or I will accept it like this. Whatever you feel comfortable with, both are fine. But the key is that you know that the point of intersection between these two lines is your answer. All right, number 2. All right, again, I suggest you just don't watch these videos. I suggest that you become an active participant. I would say right now, stop this video, watch it, work it as far as you can, and then check your answer, or if you need help, hit play and let me finish it out for you. All right, let's work on these 2. Again, for the second problem in a row, we've got 2 problems with a negative slope. All right, so let's do the first one. Y equals negative 1/2 x plus 2. Go to my y-intercept, which is plus 2. All right, the slope is 1/2. That means a rise of 1 and a run of 2 in a negative direction. So rise of 1, run of 2. Rise of 1, run of 2. Rise of 1, run of 2. I can go in the other direction and go even further, plot in a few points. Then I just need to connect my points for a line. Okay, let's do the second one. I get y equals negative 3/2 plus 4. First thing I wanted to do is go to my y-intercept. There's my plus 4. Okay, rise of 3, run of 2. And I know that it's going to be in the negative direction. All right, so I can go in this direction and go down here and plot this point, because there's my run of 2 and my rise of 3. Let's do it again. Go over 2, down 3, make a second point. I can do even one more. Okay, draw the line. All right, it's pretty obvious that the intersection is right here at 2, 1. I go to the right 2 and go up 1. Okay, that's my x, that's my y. I'll accept it like this. If you want to write it x equals 2, y equals 1, I'm fine with that. All right, number 3. Okay, our first two problems had all negative slopes. That was just by chance. I didn't plan it like that. At least number 3's got a positive slope. All right. The first one, y equals x plus 2, that's the positive slope. All right. When you see this, y equals x, I hope you remember that that means 1x. And by 1, I mean that's a slope of 1 over 1. Rise of 1, run of 1. That's the same thing as 1. Okay? So I know that y equals x plus 2 is going to be at the y-intercept right here at 2. And then it's going to be rise of 1, run of 1. Rise of 1, run of 1. Up 1, over 1. Up 1, over 1. And we can also go in the opposite direction too. Right? All you have to do now is connect the points. And you're done with that part. Okay, the next part is y equals negative 1/3 x minus 2. Okay, you know it's going to be a negative slope. It's going to be like that because it's negative. And I know that the y-intercept is at negative 2. All right. Negative direction, it's going to be a rise of 1, a run of 3. So from this point, I'm going to go up 1 over 3. Up 1 over 3. All right? And I can go in this direction if I want. So now I connect the points. The point of intersection is going to be negative 3, negative 1, and that's my answer. Okay? Right here is the point I'm talking about. Negative 3, negative 1. Negative 3 to the left, negative 1 down. You can write this as the xy point negative 3, negative 1. I will accept this. Or if you like to write it like this, x equals negative 3, y equals negative 1, I'm fine with that. All right, as far as the practice test goes, this is the final graphing question. I'll probably go at this a little bit quicker. All right, we got y equals 1/2 x minus 3. Positive slope goes in this direction. Matter of fact, they both go in that direction because you got a slope of 1/2 and a slope of 3. So the first one, y equals 1/2 x minus 3. I go down to my y-intercept, which is minus 3, negative 3. All right, the slope on this is a rise of 1, a run of 2. Rise of 1, run of 2. Okay, I can just keep doing that. Okay, then I connect the points. The second one is y equals 3x plus 2. All right, I go to the y-intercept, which is plus 2. and I know that the slope is 3. Okay, whole number 3. That means it's going to be that whole number over 1. That means the 3 is the rise, and the 1 is the run. Up 3 over 1. All right, up 3 over 1 would be there. And this goes in the other direction too. This can go over 1 down 3, over 1 down 3. So you can see where the point of intersection is. All right, these 2 points meet at the coordinate of -2, -4, which is right there. Okay, that means y equals -2. I'm sorry, x equals -2, y equals -4. All right, that's the last of the graphing problems. We've kind of beat graphing to death. I would really hope that these are easy points for you. If not, rewatch this video. It's got a little bit of everything. It's got negative slopes, positive slopes, slopes that actually have the intersection in every one of the 4 quadrants. So if you're just a little bit fuzzy on this, watch these 4 videos. This has everything you'll need to know about graphing to do well on the test. All right, number 5 starts a total of 6 problems on the practice test where we're going to be using substitution. All right, number 5, let me put that in there. All right, excuse me, let's just go ahead and get started. We have 3x plus 5 as the first equation. All right, we know that 3x plus 5 equals y. All right, since we know that from the second equation, we know y equals x plus 3, let's just substitute that in there and put x plus 3 in for y. We do that because now, without the y in the equation, we can solve for this. Let's subtract 3 from both sides. Right? If we do that, this goes away. We're left with x on the right. We're left with plus 2 on the left. And we bring down the 3x. All right. I subtract the 3x from both sides. Okay, I want to get my variables on one side and my numbers on the other. So minus 3x, right? That leaves us with a positive 2 on the left, and that leaves us with minus 2x on the right. All right, to get rid of this minus 2x, we divide both sides by -2. Right? If we do that, then the -2's cancel. We get 2 divided by -2, which is -1. All right, so we've solved for x. X equals -1. All right, I'm going to erase all this. All right, we've solved for x. X equals -1. All right, now all we have to do is put x back into one of these equations. All right, I like the second one. It's nice and simple. All right, where there's an x, I'm going to put a parentheses. All right, I'm going to put this -1 back in to the equation because I know x equals -1. And then I'm going to solve. Y equals -1 plus 3 equals 2. So there's my answer. X equals -1. Y equals 2. I can leave it like that, or I can put it into coordinates -1, 2. All right. For number 6, our second problem with substitution, let's just go ahead and jump into it. I'm going to write the first equation down. Minus 2x plus 12 equals y. But from the second equation, we know y also equals 2x minus 4. All right, so I've set these up to where there's no y in this equation, and now I can solve for it. Let's do it like this. First thing I'm going to do is I'm going to get rid of the integers on the second side, the numbers on the second side. I'm going to add 4 to both sides. Right? If I do that on the right, I'm just left with a 2x because the minus 4 plus 4 cancels out. On the left side, I have minus 2x plus 16. All right. Next thing I'm going to do is add 2x to both sides. 2x plus 2x. Okay, that way I get all the variables on one side and the numbers on the other. I end up with 4x on the right, and on the left I end up with 16. All right, I divide by both sides by 4, so these 4's cancel out, and I end up with x equals 4. So I'll write this up here on the right, x equals 4. I'm going to erase a little bit, make things easier to see. All right, I can put this x in either one. I'm going to choose the second one because it just looks easier to work with, a positive 2x. So I'm going to go y equals 2, where the x is, I'm putting parentheses, minus 4. Now, right, I'm going to substitute the 4 in for the x here. Put the 4 in. I get y equals 2 times 4, which is 8, minus 4, y equals 4. So the answer to this is x equals 4, y equals 4. I can also write it like this, and you're done. All right. Number 7, we're still under substitution. Let's just go ahead and jump into it. Minus 3x plus 10 equals y, but we're going to substitute x plus 2. We do that to eliminate all the y's, so we can just solve for x. All right, I am going to subtract 2 from both sides. I'm going to try to go one way with the variables and one way with the numbers. This leaves me with just x on the right, and on the left I've got minus 3x plus 8. All right, like I said, I'm going to go to the other direction with the variables, so I'm going to add 3x to both sides, plus 3x. Okay. If I do that, these go away. I'm just left with 8 on the left, and on the right, I've got x plus 3x. That gives me 4x. All right. I want to divide both sides by 4. The reason I do that is I've got 4 times x. To get rid of that, I want to do the opposite. Opposite of multiplication is division, so I divide by 4. These cancel out. I'm left with x equals 2. All right, I'm going to write this up here. X equals 2. I'm going to do a little bit of erasing. If you all have ever wondered, I do this on an iPad with a rubber stylus. So, yeah, I'm a little sloppy, but this is about as best I can do with the software I've got. All right. Now I want to just put the 2 back into one of these equations. It's obvious which one I want to use. I want to use the easier of the 2 equations. I want to use y equals x plus 2. I put the 2 in for the x and just solve. I get y equals 4. So that's my answers. X equals 2, y equals 4. You can also write it like this. Alrighty, we're on number 8. Y equals negative 3x plus 9. Y equals 2x minus 1. We're still under the instructions to use substitution. Alright, so I'm going to go ahead and write the first one down. Minus 3x plus 9. Alright, and I hope by now that you see that you substitute, and for the y, you substitute in the 2x minus 1 in the second equation. And then we solve. All right, I'm going to add 3x to both sides. All right, I do that so I can get rid of the x's on the right. Minus 3x plus 3x equals 0, so that just goes away. I end up with, on the left, and on the right I end up with 5x minus 1 equals 9. Right? Want to get rid of this plus 1 or minus 1 by adding 1. Okay, that goes away. Now all I've got left is variables on the right. I got 5 x's. On the left I've got 10. To solve for this, I want to divide by 5. I've got 5 times x. The way to break that up is to do the opposite, divide by 5. Right? If I do that, 10 divided by 5 is 2. So I've got x equals 2. I'm going to put this up here. And again, stop and do a little bit of erasing. All right. I think the second one looks easier. I could use the first or I could use the second. It doesn't matter which equation you use. I'm wanting to solve for y by using this x equals 2. So y equals 2, right? I put the parentheses where the x is, right? Minus 1. Put the 2 inside there, right? If I do that, I get y equals 2 times 2, which is 4. Minus 1, I get y equals 3. All right, there's my answer. X equals 2, y equals 3. In coordinates, it looks like this. All right, number 9, also substitution. And I'm going to use this as just a stopping point to say, every one of these problems, all 16 of these, some of them are siloed away, asking you to use substitution, some elimination, some graphing. You can solve any of these the other 2 ways. I'm going to do this substitution, but you have to know that I could use systems of elimination or graphing on this problem. Doesn't matter. This is just to give you 3 options. That's the way it is with algebra. You've got lots of choices. My way can be right. Your way can be right. A third person's way can be right. All right, let's get this started. All right, y equals minus 3x plus 7 equals y. Instead of y, we're going to put in 4x. All right, we've only got numbers on the left, so let's get rid of the variables on the left. I'm going to add 3x to both sides. I do this, so these go away. I end up with 7 equals 7x. All right. And I hope you can see that makes x equal 1. All right, I'm going to put this up here. X equals 1. Do a little more erasing. All right, obviously, this one's pretty easy. Take the second equation. Use that. Y equals 4 times x. Instead of x, put parentheses. Put the 1 inside the parentheses. I end up with y equals 4. So there's my answer. X equals 1, y equals 4. Final substitution problem. All right. First one, x minus 4 equals y. Instead of y, we're going to put in 3x minus 4. All right, I am going to subtract x from both sides. I want to get all my variables on the right. All right, if I do that, I end up with negative 4 on the left, and I end up with 2x minus 4 on the right. Okay, I want to add 4 to both sides because I want to have this going on. I add 4 to this side, and I end up with 2x equals 0. This just means that x equals 0. All right, let me stick this up in the corner so I got some room to work. X equals 0. Do a little bit of erasing. Right, pick either equation. First one looks the easiest. Y equals x minus 4. I put the 0 in. I get y equals negative 4. That makes my answer x equals 0, y equals negative 4. XY coordinates, I write it like this: x equals 0, y equals negative 4. All right, that's our last substitution question. We're getting ready to start elimination. And if I never said it in class, elimination happens to be my favorite. Just something about it I like. All right, like I just said, number 11 through 16 are all elimination. The first two, 11 and 12, are actually kind of the simpler elimination. I plan to have one of these on the test. It's already set up for elimination. All right, you've got these two equations, and the thing we can do, because we're mixing systems of equation, is just basically add them together. Okay, you can add the x's together, the y's together, and the numbers, which are on in this case on the right side of the equal sign, together. Watch what happens on this one when that happens. I add the 3x and the negative 3x, and I get 0. The x has been eliminated, right? I add negative 6y and 7y together. I end up getting y, just one y. Okay, on the right, I add 3 and negative 2 together, and I get 1. All right, I hope you can see that I've already solved this. You don't need this 0 and this plus. You get y equals 1. Right? So I've already solved for y. I just need to put this y equals 1 back in to one of these two equations and solve for x. I think probably the second one looks the easiest. All right? Let's put it back in the second one. I've got 3x plus 7y, so I'm going to put that in parentheses, equals negative 2. I put this negative 1 because I know y equals negative 1. Y equals 1. I put it in here. All right, let's solve. 3x plus 7 equals negative 2. All right, I want to subtract 7 from both sides. I do that so this goes away. I end up with negative 9 on the right and 3x on the left. To solve for this, I want to divide both of them by 3. Right? The 3's cancel out. I end up with negative 3. Right? So x equals negative 3. So let's write that. And make sure you get, if you put these in the xy coordinates, you get this right. X equals negative 3. It's the first one. Y equals 1. It's the second one. If you had any problem with this, watch it again. I've got a feeling, like I said, that I like elimination the best. Doesn't mean it's the easiest or anything. It just kind of appeals to me. These are the ones I expect the most problems on. So I definitely suggest, if you're a little fuzzy on this, watching it again. All right, number 12 is another one. I think like I said, that it already has it's already set up for an automatic elimination. All right, when you add these together, the x's get eliminated immediately. You add 2x to negative 2x, you get 0. Right? So I don't even have to put that 0 in there. Add the y's together. 10y plus 8y, you get 18y. You add 4 and negative 2, negative 22, you get negative 18. Divide both sides by 18. Right? You get negative 18 divided by 18 is negative 1. So y equals negative 1. Right? I want to erase this just to get some room to work. Okay, now I'm going to put this negative 1 back into one of these two equations. I like the first one because it's all positives. right? Let's do this. 2x plus 10y, that's the one I've already solved for, equals 4. I want to put this negative 1 inside there, right? I get 2x equals 10 times negative 1, right? Which is going to be negative 10, so it's going to be plus negative 10. That's the same thing as subtracting 10, equals 4. Next thing I want to do is add 10 to both sides. If I do that, I end up with 14 on the right, 2x on the left, right? Divide by 2, divide by 2. Okay, I end up with x equals 7. So the answer to this one is x equals 7, y equals negative 1. All right, number 13. Not as easy as number 11 and 12. It's still elimination, but I'm going to have to manipulate things a little bit to make it work. If you look here, nothing automatically eliminates when you add it together. But let's look at that first line. I'm going to multiply everything in it by 2. Negative 4x times 2 is negative 8x. Okay? If I multiply 9y times 2, I get plus 18y. And if I multiply 21 times 2, I get 42. So I've just multiplied everything up here on this first line by 2, and now it's the third line. I don't need this line anymore, this first one. I'm going to just put a line through it. So you can see it's still there, right? But I'm not using it. Okay, let me add these together now. Look, 8x plus negative 8x. X's are eliminated, which is what I wanted. Now I add my y's together. I end up with 22y. I add the numbers together. Negative 20 plus 42 equals 22. Right? Divide each of these by 22. I get 22 over 22, which equals 1. So y equals 1. I'm going to write it over here for now. Y equals 1. All right, I just need to put y back into these equations and solve. I'm going to use this one here. Doesn't matter which one. You could actually use any of the three, even the ones I canceled out. Doesn't matter. They're all proportionally sound. So I'm going to go 8x plus 4 times y. All right. I'm going to put parentheses in for the y equals negative 20. Right. I put my 1 in for the y, and now it's time to solve. I get 8x plus 4 equals negative 20. I want to get rid of this plus 4, so I'm going to subtract 4 from both sides. I get minus 24. 8x. Right. Divide both sides by 8. That cancels out. I get x equals negative 24 divided by 8, which is negative 3. So if I go up here, x equals negative 3. Again, I keep repeating this. I can write this like this. The x goes first, the y goes second, so I can write it either way. I can write it like y equals 1, x equals negative 3, or I can do it the coordinate pair of negative 3, 1. All right, number 4, we got 3 to go. All right, we're still on elimination. All right, let me take a look at these. Minus 3x plus 8y equals negative 26, and negative 2x plus 2y equals 6. All right, let's see. What I want to do with this one is I'm going to multiply. I want something to eliminate. So I'm going to shoot for this 2y, right here. What I'm going to do is I'm going to multiply everything on this line times -4. Right? Watch what happens when I do that. Everything times -4. I'll do the easy side first. 6 times -4 is going to be -24. Okay, -4 times -2x is going to give me 8x. And -4 times 2y is going to give me -8y. All right? So I don't need that second line at all anymore. I've multiplied everything times -4. I'm just going to erase it. Okay. Now, I hope you can look at this and see I've got stuff that eliminates. Let's add these together. -3x plus 8x gives you 5x. -8 plus -8y. These cancel out. Okay? Equals -26 plus -24 equals -50. Right? Divide both sides by 5. I get x equals -50 divided by 5 is -10. So I've got my first one. X equals -10. I've got to solve for y. Let me do a little bit of erase in here. All right. I like this top one the best. Let's use the bottom one. It's got more positives in it. So I'm solving for x. Got 8. This is the one I'm using here. 8 times x minus 8y equals -24. All right. I'm going to put my -10 in where the y is, and I'm going to solve. 8 times -10 is -80 minus 8y equals -24. I'm going to get rid of this 80. All right. Plus 80. All right. Add this together. I end up with a positive 56 on this side. And all that's left on this side is minus 8y. All right. To solve for y, I divide both sides by -8. Okay. 56 divided by -8 gives me -7. So y equals -7. In a coordinate pair, that equals -10, -7, and I'm done. All right, number 15. Keep forgetting to write the number up here. Number 15. All right, the last two are the hardest. They're elimination, okay, like the last four we've done, except I'm going to have to multiply both equations times something, because I won't be able to just multiply one number, one line. I'm going to have to do both. So here's what I'm looking at. Let me make this a different color. All right, the 3 and the 2. I need to do something to make them where they eliminate, because I want to eliminate the x's. So what I'm going to do is I'm going to multiply the top line times -3. All right. I'm going to multiply the bottom line times 2. The reason I'm doing that, this will make it where the x's are eliminated. So let me multiply the top line times -3. If I do that, I get -6x minus 15y equals minus 90. All I did was take this negative 3 times each one of these. Negative 3 times 2x gives me negative 6x. Negative 3 times 5y gives me negative 5y. Negative 3 times 30 gives me negative 90. All right. I'm basically just going to double the second line. I end up with 6x, double the 3x, plus 6y, double the 6y, equals 36. All right. Now you can see, the reason I did all that was, now I've got negative 6x and 6x. They eliminate each other. All right. Let me add the rest of it together. Negative 15y and 6y, right? That's going to give me minus 9y equals, all right, add negative 90 and 36, I get minus 54. Divide both sides by negative 9 because I want to get y by itself. I'm left with y equals negative 54 divided by 9 equals 6. So number 15, I know that y equals 6. All right, I'm going to stop here a second, do a little bit of erasing so I've got some room. Okay, y equals 6. I'm going to use this second equation. This one looks like the easiest to use. Okay, I have 6x plus 6y equals 36. I put parentheses in for y because I want to go ahead and substitute this in. Okay, y equals 6. I end up with 6x plus 36 equals 36. All right. Subtract 36 from each side, I get 6x equals 0. I subtracted the 36 from each side, this one and this one. And that means x equals 0. So those are my answers. I can write it like that, or in a coordinate pair like that. This one was a little tough, all right? I had to multiply both of these times something, both of the equations. So if you had problems with this, rewatch it. The concept is the same. If you understand it, you'll be able to get it even if it's different numbers. So give this one a little bit of time. All right, final question. All right, number 16. I thought this was going to be one that was going to be like number 15, where I had to multiply both lines times something, but it turns out that's not the case. I only have to multiply the second row. All right, look at this. I got minus 4x on top. I've got minus 2x on the bottom. I want that second line to be positive 4x. Right? To do that, if I multiply that whole row by negative 2, that should give me what I want. So negative 2 times negative 2x would give me positive 4x. Negative 2 times minus y is going to give me plus 2y. Negative 2 times negative 20 is going to give me positive 40. Right? I've multiplied that whole second row times negative 2. I don't need it anymore. To keep down confusion, I'm just going to get rid of it. All right. I've got what I want here. I've got minus 4x plus 4x. They eliminate. The x's are gone. 7y plus 2y gives me 9y. All right. 14 plus 40 gives me 54. Divide both sides by 9 to break up that 9y. So then I've got y equals 54 divided by 9, so y equals 6. Let's put this over here, y equals 6. Do a little bit of erasing. All right. Well, actually, I erased one of the lines, but it doesn't matter. You can use either one of the equations. Let's use this one. I've got minus 4x plus 7y equals 14. All right, I want to insert my y, 6. I get minus 4x plus 7 times 6 is 42 equals 14. I'm going to subtract the 42 from both sides. Okay, I get minus 28 on the right, and on the left I get minus 4x. Divide both sides. I got negative 4 times x. I want to divide by negative 4. Negative 4. I end up with x equals 7. When you divide a negative by a negative, you get a positive. 28 divided by 4 is 7. So x equals 7. And there's my answer. 7 and 6. All right, that's pretty much it. It's Friday night, I guess about 10 o'clock as I finish this up. I'm leaving on vacation tomorrow. I'm going to Gatlinburg for a few days. I will see you all bright and early on Tuesday. I hope you watch this. I hope you find this helpful. I'll be checking my emails, so if you got any questions, email me. It's not a big deal. I sit around, play on my email at night, or check my email, play on my computer a little bit. So feel free to send me any questions you might have. Good luck. Hope you all have a nice, safe weekend, and hope to see you on Tuesday.